Hi, my name is Jonathan Hopp. Today we're going to go over asynchronous programming in C Sharp. Now, this is a pretty difficult topic for a lot of folks, and I'll be honest with you, you can go through a lot of your programming career and just follow the pattern that C Sharp lays out before you and you'll be fine. But it really is important to kind of understand like what is the computer actually doing. And asynchronous programming is commonly misunderstood among programmers, so it really is good to kind of brush up on it because especially if you're doing like web development, you'll definitely be doing asynchronous programming. So what is asynchronous programming? Essentially, human beings think about things in order. So for example, when we do like synchronous programming, things in order, I tell the computer to do task A, then do task B, then do task C. Human beings understand that, right? You do A first, and when A is finished, then you start on B. Task B cannot be started until A finishes. Task C cannot be started until B finishes. So if task A takes a long time, well then, tough luck, right? Like we have to wait until task A is finished and then we can move on to task B. Asynchronous programming is a little hard to understand because the human brain doesn't really work like that. Asynchronous programming says, okay, we got task A, we're going to have the computer start on task A, and when it's done, come back and let me know. In the meantime, I'm going to go ahead and continue on and work on task B next. And that's kind of weird because then we have this spinning plate mental image, right? So like task A is a plate that we're going to put the plate on the stick and start spinning it. And then we're going to have task B and put that on a plate and start spinning it. And the computer will let us know when it's done, like when it's completed the task, or there's an exception thrown. All right, so essentially we have all these spinning plates. Now, this makes our program more efficient usually. Now, there's times when you don't want to use asynchronous programming, but the times you do, the idea is that you basically don't really want the computer to wait until task A is done, right? You don't want like the computer to be blocked to where if task A takes a long time, nothing else gets done except for task A. Because that first off, it could be a very bad user experience, and secondly, frankly speaking, if the computer is waiting around for task A to be done, the computer could be working on something else. There's other resources. The resources of the computer could be put to better use. All right, so asynchronous programming is not necessarily about speed. It's more about using your resources efficiently. You don't want any of your resources, like for your threads, for example, to just be sitting around and doing nothing, right, when there's work to be done. All right, let's go over the basic syntax of how to do an asynchronous method. So I have this basic async example class, and let's go over like a regular method. Now, if you're not up on C Sharp, this tutorial might be a little bit difficult for you, but I do have a beginner's tutorial on C Sharp. Link is down in the description, so if you need to, take a look at that. But let's go ahead and just make a regular method. Let's say I did public void say hello. Console.writeLine, hi there. All right, and this is a synchronous method. All right, so essentially, if I told the computer to run this, it would run this and wait to do anything else until afterward. All right, so how do I make this asynchronous? Well, C Sharp has keywords. Okay, it's called async await. All right, so the method's going to be asynchronous. So what I'm going to do is I'm going to change the signature. I'm going to make it async. Now, we don't want to do async void because void doesn't actually return anything. So what I want to do is do task. And now you're like, what the heck is this task thing? All right, so let's break this down a little bit. First off, this async comes after the public private, like what the access modifier for the method. Then afterwards, you have a task. And what is a task? All a task basically is a unit of work whose finish point is sometime in the future. I know, mind melting. All right, so basically all that means is, hey, this is a unit of work. This is like a set of instructions that the computer is going to do. And when it finishes is sometime in the future. When? I have no idea. All right, it will get back to me and let me know when it's done. So the cool thing about a task is, in this case, this doesn't return anything, right? So I'm just writing like hi there. You could also have a task that contains some information. So for example, I could do async task string, okay, in the angle brackets. And what I'm saying is that, hey, this method in the future is going to give you back a string. When in the future, I don't know, like it could be in 2 milliseconds. It could be in 2 seconds. I'm not exactly sure, but hey, whenever this method is done doing its job, at the end, it's going to give you a string. So you could just basically go ahead and do like return, and then just like a normal string. So like return, oops, hi there. Okay, so I'll get rid of this console write line here just to make it nice and understandable. All right, so all this is an asynchronous method. All right, which basically means the computer is not going to stop everything it's doing and just do this. It's going to get started on it and then maybe go take its resources and go do other stuff. And then it will get back to us and say, okay, cool, I've done everything inside of the function. Here's your string. Okay, I've completed my task. Here you go. Here's your string. Here's your Boolean. Here's your object. Or if you don't want to give back anything, you can just be like a task, and then of course it wouldn't return anything, right? That'd be equivalent of void. All right, so that is essentially how we mark a method as asynchronous. Now, how do we actually use this? All right, so I'm going to go to program.cs. I've got my basic example. Now, the other part of async is called await. So, for example, we would like to actually do this method, right? So we'd like to actually async task string. So I'm going to do var greeting equals. Now, if we just do, let's do say hello. If we just do this, okay, we're doing an asynchronous method, right? So essentially, I want to let the computer know. I want to basically say, hey, computer, go do this task and let me know that you're done, right? I don't know when this method's going to be done. Logically, I have no idea. So to let the computers know, hey, I'd like to actually make you go and do your job and then come back. We're going to do await before it. So we're going to do await bay.sayhello. All right, and then I will do console.writeLine greeting. All right, let's run this. And bam, there we go, hi there. So you're wondering, Jonathan, I really need this await. Well, let's get rid of it. Let's see what happens. Well, what the heck? That's not hi there, right? That's system.threading.task. What the heck happened? So line 6, if we don't have a wait, it will just give you the task. And you could think of it this way. It's sort of like I'm handing you some work I've been doing at a random point of me working on it. Hey, I've been painting this painting and you just took a snapshot today. Here you go. Right? You didn't wait for me to actually finish drawing the painting and putting the colors and everything in. You just came up at a random time and just said, okay, cool, give me whatever you got. All right, so we need this await to basically say, hey, I would like to get the result of this method when you're done with it, whenever that is. Notice how when I didn't have it, it just went straight on. But when I have it here, it's going to basically say, okay, cool. Eventually, you're going to give back a value, and I'll be able to do console.writeLine greeting. Right, then we get hi there. All right, so now we know the basic structure of how we make an asynchronous method. Okay, we're going to use this async keyword. Then we're going to use a task. If you need to return a value like a string or a class or Boolean, you can use angle brackets to give the type. Okay, and after that, it works just like a method. When you want to call this method, you need to have the await keyword in front of the method that you're using. So, for example, doing await bay.sayhello. So that way, I'm basically saying, hey, go do this unit of work. Go do this task. And whenever you're done, come back to me and give me back my value that I'm expecting. So asynchronous programming is all about basically is a way of basically writing out saying, hey, this is actually representing a future value. But human beings, we don't really think like that. So this whole async await allows us to write out things in a way that our human brains are comfortable with, but we can represent asynchronous basically saying, hey, go do this, and whenever you're done with it, come back to me. Now, you're probably wondering, well, what is the point of asynchronous? Does it really matter, right? Because essentially this is adding a layer of complication to our program. We already had a synchronous say hello method, right? That was fine. Now I have to do all this await stuff, and if I forget the await, bad things happen. What is the advantage of doing this? Let me give you an example. All right, let's imagine that we work in a restaurant, a really busy restaurant. We got great food, right? We got people coming in, they want gumbo, they want etouffee, they want crawfish, they want everything. Okay, awesome, that's good for our business. So I have this class called order. Now, here's the thing. Some orders are going to take more time to cook than others. A person comes in and orders a cup of soup. Easy, okay? Cup of soup, put the thing in the bowl, you're done. Then that compared to, let's say, a table of 10, right? They're at a wedding reception or something, right? 10 people come in. That's going to take a lot of time to cook all their food. So some orders are going to take way more time to complete than others. So what I have is this order class to represent that. Each order is unique and has its own ID and has cooking time in milliseconds. How much time is it going to take the chef to cook this? Again, some orders are big, some orders are small. Now, I've got two chefs, synchronous chef and asynchronous chef. So let's take a look at them. All right, synchronous chef is a rather handsome guy. He can process orders. He takes in a queue of orders. Now, some people may not know what a queue is. It is a data structure. Very simply, you could think of it like people waiting in line. There's a person at the head of the line, there's a person at the back of the line. The first person in line is the first person out of the line. So if you're the first person in line, then you're they say next, and then you go, and then next, then you go. So you can think of it just like a line of people. All right. So what the synchronous chef does is he gets a queue of orders. Then he goes one by one and does the orders. All right, and so here, line 10 might be new to you, thread.sleep. All right, what is a thread? A thread you can think of, a good analogy is a worker bee. All right, so you can think of your program like a hive. It's got a bunch of different moving parts that are doing all kinds of things. A thread is like a worker bee. A thread is basically like, okay, cool, I have a job. It can do a job, a task, and it can do one thing at a time. It will go through the task step by step by step by step until the task is completed. So a thread will be like, okay, cool, I've been assigned to work on something. I will then work on it until it's done. C# is a multi-threaded language. So actually C# has what's called a thread pool, basically like a team of worker bees that it just gets, right? So when you start up a C# program, the computer will say, you get these worker bees. And like, okay, cool. So what I'm basically saying is, hey, worker bee, go to sleep, okay, for the amount of time it takes to cook the order. This is to simulate the chef cooking the order, right? Like the frying on the frying pan and I don't know what else, like putting stuff in boiling water, all right? So this will last for a different amount of time depending on the order. Then we're going to console.write line, hey, synchronous chef completed this order. Now, asynchronous chef is a little bit different. Asynchronous chef works on things asynchronously. So synchronous chef does things in order. You have 10 orders. You do order number 1. You do not start on order number 2 until order number 1 is done. Okay, so that means until order number 1 is done, all other orders just sit there and wait. Asynchronous chef, all right, has like multiple hands. He's got like the villain from Spider-Man. Right? He's got all his arms. All right, so what he can do is he can take an order and get started on it. And then he can take another order and also get started on that one. And then he'll let his sous chefs will let him know like when they're done with the order and give it back to him. So he has his cook async, all right, where again, we're going to do this task.delay. Now, this is different than thread.sleep because again, for asynchronous, we're doing a task, a unit of work. Cooking, like basically preparing an order. We're preparing an order is our task. Okay, and for each task, we will wait an amount of time equal to the amount of time it needs to cook, and then we'll print out. So async task process order, remember that async keyword says that this is an asynchronous function. It is a task, so it's not going to return anything. It takes in a queue of orders. I then am going through all the orders, and I'm basically making tasks out of them. I'm basically saying, here's an order. I'd like you to create a task that represents sometime in the future when you will be done cooking this order. When is that? I don't know. Right? But the task represents the future. Okay, some future events, some future, I'm done doing this. And then it will do the task.whenAll will basically go through all the tasks at that point. All right, so this is a little bit mind-bending because the human brain does not work like this. We think of step 1, step 2, step 3. This is step 1, step 2 are happening simultaneous while step 3 is going on, right? That is not how humans work. Okay, but asynchronous chef can do more than one thing at once, okay? And the cool thing about asynchronous chef is he's always working. The big thing about asynchronous chef is he's always doing something. Synchronous chef, for example, might be like frying up some steak. And then he's not doing anything else. Like he has another order. Like for example, he could be working on order number 2, at least getting some of the preparation started, like cutting up the onions or, getting the soup ready or heating something up. But he doesn't do anything on order number 2. He just stands at order number 1. If he's just standing there grilling steak, he's kind of wasting his time. He could be using that time. The steak isn't going anywhere. It's going to sit there on the grill. He could turn around and start working on some other stuff, but instead he's just staring at the steak until it's done. Now, because Asynchronous Chef is more efficient with his orders, he's always working, he's always moving, he's chopping onions, he's chopping up mushrooms, he's frying this, he's reheating that. Which one's going to be faster? So I've got some code here, and again, I'm going to break it down for you. Don't look, it's a bunch of asynchronous programming. It's really not that hard. I'm going to generate 10 random orders. So essentially, each order is going to have a random number between 100 milliseconds to 2,000 milliseconds. That way, some orders are big, some orders are small. So that means some orders take up to 2 seconds to fulfill. Some orders are super quick and take only like 100 milliseconds. All right? Each chef is going to get the exact same orders. Okay, I'm going to basically give them exactly the same queue of orders, so there's no difference. I am then going to use a stopwatch class to basically say, okay, cool, Synchronous Chef will process his orders, he'll let us know when they're done, and then we're going to time him. I'm going to see how long does it take Synchronous Chef to complete 10 orders. I'm going to give the same 10 orders to Asynchronous Chef and see how long it takes him to complete them. So let's go ahead and run this and see what happens. Okay, order 2 completed, order 3. See how some orders are slower than others? Some are faster, some are slower. But Synchronous Chef just does them one after the other. Let's look at Asynchronous Chef right here. All right, Synchronous Chef I think is pretty straightforward. He did all the orders 1, 2, 3, 4, 5, 6, one at a time. Asynchronous Chef, like I said, he's all over the kitchen. Asynchronous Chef started on order number 9 and then went to order number 2 and then did order number 7. Huh? So Asynchronous Chef, you can think of it like I said, he is never just standing around waiting for something to cook. He's always doing something, whether it be boiling water, cutting up vegetables, putting something in the microwave, restocking meat, preparing a sauce. He's always moving at every given moment. Synchronous Chef just does not do any extra work until the thing is done. All right, so notice Asynchronous Chef also does not necessarily complete the orders in the order that they came in. Synchronous Chef does things in order, 1 through 10. Asynchronous Chef does not necessarily complete the orders in the order that they came in. So maybe order 9 was really quick. And then, okay, if order 9 is really quick, then yeah, just go ahead and do that. And then order number 2 can be done. Maybe order number 5 was like one of the longer ones. Okay, he had that going in the background. So you see, Asynchronous Chef is not bound by the order that things came in, whereas Synchronous Chef is. Okay, I'm going to run this again so you kind of can appreciate it. Okay, so Synchronous Chef just, again, does things in order. Some of these orders are quick, some of them are slow. It just depends. Maybe we have a party of 10 or a party of 2. Right, but he doesn't write in order. Asynchronous Chef, okay, he is always moving, so he can move through these different orders. Notice how Synchronous Chef, it took him 9,827 milliseconds, about almost 10 seconds, to do all his job. But Asynchronous Chef was moving 1,700 milliseconds. He was like under 2 seconds. He was able to do this, all of his work. Asynchronous Chef, because he's always moving, because he's always doing something, can complete more work in the same amount of work in less time. Now, let's kind of crank it up a bit. Let's talk about threads. You can see how that works. All right, so what I've done is I have some extra console.write lines in both Synchronous Chef and Asynchronous Chef. So if you want to, there's a GitHub repo down in the description if you'd like to see the code for this. All right, so now what I'm going to show is which thread is working on what. Now again, back to threads. Threads are like worker bees. C# has what's called a thread pool. Essentially, it's a bunch of worker bees that are assigned to your program once it gets started. Your program's like a hive of different bees doing different things. For example, there's the main thread, which is the queen bee. The main thread is what starts up when you start your program. That one's not allowed to stop. Okay, we're not allowed to like block that. That needs to just keep on going while the program runs. You've got worker bees though. You got a whole pool of them. And you can pick a worker bee. They're all the same. One's no different than the other one. And what C# does is it says, okay, cool. I got a task. I got something to do. I'm going to go pick up a worker bee. And the worker bee will do my constructions until they're all done. Now, Synchronous Chef, okay, because he works on the same thing over and over again, he basically just works on things in order until they're done. He's going to pick up a thread, and that thread is going to do the work until it gets on to the next task. Okay, so it's just going to do everything synchronously. Watch what happens with asynchronous chef though. So each thread has an ID. It's called a managed thread ID. A thread.currentThread.managedThreadID. Basically, the ID of a thread lets you know, like, hey, this is this unique thread. Threads are otherwise no different from one another, but they are given IDs. So that way you can know like who's using what thread. All right, so they have all of a unique ID. I'm going to run my program, and I want you to take a look at something. So Synchronous Chef is always using thread 1. So Synchronous Chef takes thread 1, and thread 1 is always doing all of his work. Asynchronous Chef mostly uses thread 9, but he also uses thread 5. What does that mean? Synchronous Chef uses one thread. Now, thread 1, okay, could be used for other things. These worker bee threads, okay, they're for use by your program. And your program has a bunch of stuff, like I said, it's a hive. There's a bunch of stuff happening at once. Thread 1, there was a period of time where thread 1 was just kind of chilling. Like, it wasn't doing anything. It was basically waiting for the order to be done. Like, some of these orders were a lot longer, right? It was waiting like a full second for the order to be done. That second could have been used to do some work, but the thread was like, nah, we're synchronous. I'm just going to sit here and wait till the thing is done and then move on to the next thing. Asynchronous Chef, he can grab multiple threads. So he can be like, hey, I'm going to grab thread 9, and thread 9 will work on order number 8. Order number 4 is taking a long time, so this next order, number 2, we're going to have thread 5 work on that. Okay, remember, each thread is no different than the other thread. Doesn't really, thread 9, 5 are just numbers. All right, so Asynchronous Chef is always, this is how Asynchronous Chef is always doing something. He's always working. He's cutting up onions. He's restocking the fridge. He's always doing something. Now, one common misconception about asynchronous programming is that like you're just pulling another thread. Not necessarily. There's other scenarios in asynchronous programming where, for example, let's say you're working with the CPU. You're doing like opening up a file or closing a file. Working with the file system is not necessarily working with a thread. You're working with the CPU. Now your computer, you're basically telling your computer, not like C#, but like your actual computer, your actual CPU, your actual hardware on your computer, hey, go open up this file or go write this to this file on your hard drive and let me know that you're done. That's not using a thread. All right. So when I say resources on your computer has all sorts of stuff that does all kinds of work. And we want to make certain that all these different things, your hard drive, your CPU, the threads, all this stuff is always doing something. We try not to have a moment in time where it's just sitting there doing nothing. That is the point of asynchronous programming. Now, in this case, this is C#, we're using threads, so the asynchronous chef just grabs another thread to, keep working. So that's why, because he has all these threads he can work with, he can like basically always be working and therefore do the work faster. So if I run it again, you notice that he uses different threads. So for example, Synchronous Chef is still on thread 1. Yeah, order 5 took quite some time. Here he goes, he keeps going. All right, Asynchronous Chef, okay, switches between 5 and 8. Okay, he gets to, do more work. And because we have 2 threads working on their own respective thing, that means that in that unit of time, I'm getting more done. All right, so this is the benefit of doing asynchronous programming. All right, so hopefully that you understand better like what asynchronous programming is about. If you like this video, you like these lessons, I love talking about .NET, I love talking about C# and other programming languages. So in the comments below, please let me know like what topics do you want me to talk about next. It doesn't have to be .NET or C#. There's a whole world of different things we can talk about, but like this video, put something in the comments, and of course, be sure to subscribe. And thank you for watching. I'll catch you guys next time.